All right, let's do some warm-ups. It's a review from previous stuff. Evaluate the expression. All I need to do here is draw my 45, 45, 90-degree triangle and label it. So cosine of 45 is ca, adjacent over hypotenuse. So 1 over the square root of 2, which I need to rationalize. So I multiply by the square root of 2 over the square root of 2. Gives me the square root of 2 over 2. All right, sine of 5 pi over 6. I don't know how many degrees that is, and I could work on it with radians, but my mind just works a lot better with degrees, so I'm going to go ahead and change it. 5 times 180 divided by 6 is 150 degrees. So I know that's somewhere in quadrant 2. I'm not sure where, so I'm going to subtract 90 from it. That gives me 60. So I'm actually at 30 degrees. So I have another special triangle. I need to remember what those measurements are. So that's the triangle I need to have memorized. Sine is opposite over hypotenuse. So sine of 5 pi over 6 equals 1/2. Now if I go tangent of negative 60, I'm going this direction. 60 degrees. So this is a special triangle. Across from the 60 is square root of 3. Across from the hypotenuse is 2, and across from the 30 degrees is 1. So this is 30. So tangent is opposite over adjacent. Opposite over adjacent is square root 3 over 1, or just plain old square root 3, but I'm in the negative direction, so don't forget that negative. Evaluate the expression. Cosine of pi. That's right here. We don't have any other information, so I know this is the unit circle. My point right here is -1, 0. Cosine is x over radius. So my x value is -1, my radius is 1, so my answer is -1. And now we have tangent of pi over 6. 6 divided by 180 is 30, so we're going -30 direction. So here we have 30, 60, there's 90. We just did this, so across from the 30 is 1, across from the 60 is square root 2. Sorry, that's wrong. Across from the 90 is 2, across from the 60 is square root 3. So I'm tangent there. Tangent is opposite over adjacent, so opposite over adjacent. Need to, rationalize that, so I'm multiplying square root 3 over 3. But this is negative, so my answer is negative root 3 over 3. Cool. Let's get into some actual new stuff, right? Okay. First of all, this is directly from your book. I'm going to go ahead and read it. So reading from your book, and I'm copying this for you. So far in this chapter, you've learned to evaluate trig functions of a given angle. But today, we're going to study the reverse problem, finding the angle that corresponds to a given value of a trig function. Okay? So first of all, suppose you were asked to find an angle theta whose sine is 0.5. So I say that sine of theta equals 0.5. So we're trying to figure out what the angle is. So after considering the problem, you realize that many such angles exist. For instance, 0.5, which is the same as 1/2. That works for pi over 6, which is 30 degrees. That works for 5 pi over 6, which is also 30 degrees reference angle, right? That works for 13 pi over 6. So this statement is valid for many different angle measurements because we go round and around and around our circle. So to obtain a unique angle of sine theta equals 0.5 or 1/2, you must restrict your domain, which is your input. You have to restrict your domain. Domain restrictions let you allow the inverse sine, okay? Inverse cosine, inverse tangent functions to be defined. So let's read through this paper. So if -1 is less than a is less than 1, then the inverse sine of a is an angle theta written theta equals sine to the -1 of a. Okay, sine to the -1 of a. I guess let's do, so we've got this one written. I would say sine to the -1 of 1/2 equals theta is what we're referring to. Okay, so back to our example where sine theta equals a, so it's no longer -1, right? So theta equals sine -1 of a, therefore sine theta equals a. These go back and forth. Theta has to be between -90 and 90. So theta is between -90 and 90. It's the only place it's valid for. All right, so next, if -1 is less than or equal to a is less than or equal to 1, then the inverse cosine of a is written theta equals cosine -1 of a. So cosine theta equals a, and theta has to be in between 0 and pi. Theta has to be here. Keep going. If a is any real number, then the inverse tangent of a is an angle theta, where theta is tan to the -1 of a. So tan theta equals a, and my angle measurement is between -90 and 90, right there. Okay, hopefully this makes more sense with some examples. So let's go. All right, so evaluate the expression in both radians and degrees. So this is cosine -1. If I go back to the chart on the previous page, I've said that 0 is less than or equal to theta is less than or equal to pi, or 0 is less than or equal to theta is less than or equal to 180. So I can say that theta equals cosine -1 of root 3 over 2 using my 30, 60, 90 degree triangle. I know root 3 over 2 is adjacent over hypotenuse. Adjacent over hypotenuse is valid for theta equals 30 degrees. How about sine to the -1 of 2? I don't have, wish I didn't have to draw this every time. 30, 60, 90, across from the 90 is 2, across from the 60 is root 3, across from the 30 is 1, or even my 45, 45, 45, 45, 90, 1, 1, and root 2. For the sine function, which is opposite over hypotenuse, opposite over hypotenuse, that's not 2. Opposite of hypotenuse, that's not 2. Yeah, because my hypotenuse is always in the denominator. That doesn't work. Opposite over hypotenuse, opposite over hypotenuse. So there is no angle that works for that function. So we say it's undefined. Okay, tan root 3, that looks like it might be my 30, 60, 90 degree triangle. Let's see, 2, 1, root 3. So tangent is opposite over adjacent, so 1 over root 3, that doesn't work. How about root 3 over 1? That works. So root 3 over 1 is 60. I need to get my sign right though. Theta equals 60. If root 3 is negative, or 1 is negative, let's see if I've got my unit circle. If I went this way, I'm just trying to figure it out right now. So across from the 60 is root 3. So I can say tangent is opposite over adjacent. That doesn't work. Nope, it does. I got this wrong. 2 and 1. So this is opposite over adjacent, and that's negative. So this would be negative 60 degrees. All right, not sure here, so let's figure it out together. I'm in between 180 and 270, so I'm somewhere in this quadrant. Sine theta equals negative 5 over 8. So sine theta equals negative 5 over 8. That means that sine to the negative 1 of negative 5/8 equals theta. So I'm going to type into my calculator exactly what I see there. Sine to the negative 1 of negative 5 divided by 8 gives me, please make sure your calculator is in degree mode. I've got negative 38.7. So negative 38.7 is here. Okay, but that's not in the range of what we were asked. I need to be there. So let's figure out what that means. So if I go over here, that's going to be negative 38.7. But it doesn't quite help. So I have to add 180 and 38.7. So 180 plus 38.7 gives me theta equals 218.7 degrees. Okay, we can actually check this. So I'm going to type into my calculator sine of 218.7 and see what I get. Sine 218.7 gives me negative 0.625. If I change that into a fraction, I can't. Let's do what is 5 divided by 8? Equals 0.625. My calculator had too many decimals in it, so it would not change into a fraction. So we got it. We checked it and we got it. All right, evaluate the expression in both radians and degrees. So let's go ahead and try it. Square root 2 over 2 makes me think of the 45, 45, 90 degree triangle, which I have 1, 1, and square root of 2. Sine of this, using the triangle, I'm actually going to change, if you remember, square root 2 over 2 is the same as 1 over root 2, because we always have to rationalize that thing. Cool? So sine of 45 is opposite over hypotenuse, which is 1 over root 2, which rationalizes to root 2 over 2. So theta is 45 degrees. If I change 45 degrees into radians, I get theta is pi over 4. Okay, next, cosine 1 over 2. that only works with the 30-60 degree triangle. So 60, 30, nope. 1 over 2 is adjacent over hypotenuse. So I can say cosine is adjacent over hypotenuse, so that works. My angle would be 60 degrees, which is also pi over 3. Okay, tangent is -1. That's my 45-45 degree triangle. So that's opposite over adjacent. So I'm at 45 degrees, but I'm not sure where. I'm out of space. Okay, I'm going red. So opposite over adjacent. If we did this 45 degree angle, I'd be -1 over 1, and that would work. So negative over, that works. So -45 degrees, which is the same as negative pi over 4. And last but not least, -1/2. 1/2 is in my 30-60 degree triangle. Let's see how many of these I've drawn today. 30, 60, 90. One half sine is opposite over hypotenuse. So I can say opposite over hypotenuse is 1/2. That means my 1 needs to be negative. So across from the 1, there we are. Cool. So that's -1. So opposite over hypotenuse gives me -1/2. So I'm at -30 degrees, which is negative pi over 6. All right. So for this first one, between 270 and 360, I'm in this quadrant. So let's do cosine to the -1 of 0.4. Cosine to the -1 of 0.4 is 66.4 degrees. So I could say negative 66.4 degrees. Or I have to get all the way over here, which would be 360 minus 66.4. Which is 293.6. So either one of those answers would work. How about tan to the -1 of 2.1? Remember, you need to be in degrees. That's 64.5 degrees, but I need to be in between 180 and 270, which is this quadrant. So I'm going to go 180 plus another 64.5. That gives me, 244.5 degrees. Now, sine to the -1 of -0.23. Between 270 and 360 is over here. Sine -1 of 0.23. Forgot the negative sign. -0.23 is -13.29 degrees, which works. That would be straight down, but I can also go this direction. So if I do 360 minus that, I'm at 346.7 degrees. Still going. Tan -1 of 4.7. .98, so 78 degrees. I need to be between 180 and 270. And I can be there if I add 180 to it. That gives me 257.988. So 258 degrees. Sine -1 of 0.62 is 38.3. Make sure that's in between 90 and 180. So I need to add 90 to that, which gives me 100 and, nope. So 90 plus 38. Yeah, that puts me over there. 128, but my reference angle, nope. So 180 minus 38.3 is 141. I did that backwards, so I need this reference angle to be 38.3. So this measurement would be 180 minus 38.3, which is 141.7. Sorry, I did that one backwards. Cosine -1 of -0.39 equals 112.95, so 113. 113 is not in between those two. Between 180 and 270 is right here. So to get 113, I'm actually going to take, 360 minus, and that gives me 247 degrees. Cool. Moving on. Okay, example 3. What is the measure of the triangle theta in the triangle shown below? So I'm not sure, but I know theta can be adjacent over hypotenuse, which is cosine of 6/11 equals theta. So let's do it. Cosine -1, 6 divided by 11, and that gives me 56.9 degrees. Right, write and solve a trig equation. A monster truck drives off a ramp in order to jump onto a row of cars. The ramp has a height of 8 feet and a horizontal length of 20 feet. What is the angle theta of the ramp? So there's theta. I'm not sure, but I know it's opposite over adjacent. So I can do tan -1 of opposite over adjacent, and that'll give me a degree. This is where trig stuff is useful. I got 21.8 degrees, and that works. See, trig is useful. Alright, try those a few. Find the measure of angle theta. Here, you just have to, like, this is my hypotenuse, and that is adjacent. So the only thing with adjacent and hypotenuse in it is cosine. Adjacent and hypotenuse. So cosine to the -1 of adjacent over hypotenuse equals theta. Plug it into your calculator, and you've got theta equals 63.6. When there's no domain restrictions, it's pretty simple, right? Alright, I have theta I have opposite over adjacent. That's tangent. Tangent -1 of opposite over adjacent is 51.3 degrees. Okay, I've got theta. This is opposite in my hypotenuse. That's sine. Sine -1 of opposite over hypotenuse. Easy peasy. So what if, in example 4, that was our monster truck. Suppose a monster truck drives 26 feet on a ramp before jumping onto a row of cars. If the ramp is 10 feet high, what is the angle of the ramp? So here I have opposite over hypotenuse. That's sine. So times the -1 of opposite over hypotenuse. That's a 20. So sine to the -1 of opposite over hypotenuse. That means theta is 22.6 degrees. Great. These are the ones you can practice. I'd love for you to practice them on your own. Let me go ahead and give you some answers. Here I've got -pi/3 or -60. Here I have 111.8 degrees, 33.6 degrees, and about 25 degrees. That's it. Good job.